Station 3 is back titration of antacid, and these are the equipment and material. You have antacids that has calcium carbonate as active ingredient, hydrochloric acid, then you have sodium hydroxide, phenolphthalein, your indicator, and burette. Of course, we also have a graduated cylinder for the acid. So in this example, I'm going to make up the numbers, but then you use your own numbers. I'm using 35 milliliters of 1 molar hydrochloric acid. I'm adding it to antacid in a beaker, let it react, and then I'm going to, after a while when the reaction is performed, I'm going to titrate the leftover hydrochloric acid with sodium hydroxide 1 molar. In this example, I used 11 milliliter of sodium hydroxide to neutralize my unreacted portion of the acid. So now let's go after calculations. First, I go after the second reaction. That's why it's known as back titration. The reaction is between HCl NaOH. It's 1:1 ratio of moles. 11 milliliters of HCl was used in this process. So if you subtract from the original volume 35, you see 19 milliliter was used for the antacid only, if you follow this calculation. The next thing to do is we are going to find out how much calcium carbonate we have. So 19 milliliters of acid times its molarity gives us the moles of HCl. Now if you look at the ratio of CaCO3 versus HCl, it's 1:2, so then I divide it by 2 and I find my moles of calcium carbonate. Finally, I find mass of calcium carbonate in the tablet, which is moles times its molar mass, and I get to have 0.950 grams. On the bottle, I see there is 1000 milligrams of calcium carbonate, so this becomes my theoretical value. And then we are ready to calculate percent error and uncertainties. So once again, let's just look at the calculation we did. From after titration, we subtracted the volume of the acid from the original volume. We found milliliters of the acid. We converted that to moles of HCl. We looked at the equation and we find moles of calcium carbonate. Finally, mass of calcium carbonate. Now, percent error is theoretical minus experimental divided by theoretical in absolute value, and in this case I got 5% error. Experimental error. Percent uncertainties, there is 1 for NaOH in the burette, 1 for HCl in graduated cylinder. Burette, since the 11 ml was 2 readings 0 and then 11, I'm adding both absolute uncertainties. Burette was analog, so it's the half of the smallest reading. And graduated cylinder is also half of the smallest reading, which is 1 ml, so that's 0.5. You divide by the number times 100, divide by the number times 100, and I get 2.3% uncertainty. In this case also, since percent error is bigger than total percent uncertainty, then we have combination of random and systematic. One more time, random errors can only be reduced by repetition of the trials and also upgrading the precision of the equipment.